Hello, 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 everybody, and welcome back. Root Beer here with question number 3 on the 2009 Grade 7 Gauss contest. Now, before I proceed, I did make a little bit of a goof in the last video. I didn't do anything wrong. For question number 2, I forgot to bubble in my answer, or rather, I forgot to record my answer on my notepad. But our answer from the last question was 24 meters. It is C, just in case people were missing out on that. All right, now, let's forget all that and move on to question number 3. How many numbers in the list, 11, 12, 13, 14, 15, 16, 17, are prime numbers? So we have to remember what prime numbers are. And some of you out there will actually know a lot of prime numbers. I usually tell high school students when they're doing these contests that one of the great things that you should know, just sort of off the top of your head, would be, prime numbers less than 100. Being able to recognize, 89, that's a prime, but 57, that's not a prime number, can be a great asset to you and make a lot of your calculations on future contests go quickly. Just like memorizing the squares up to 30 squared can be good. Okay? But, it's an early question and it's a grade 7 contest. What should we remember about prime numbers? Well, prime numbers are numbers that can only be written as a multiple of two numbers where one of those numbers is 1. Another way to say this is prime numbers have only two factors, 1 and themselves. Okay? So if I take a look at this list and I ask, 15, is it prime? I have to ask myself, is there a way I can write 15 as something times something and neither of those is 1? Because if I can, suddenly I've got other factors other than 1 and 15. And for 15, I absolutely can. 3 times 5 is 15. Okay? So let's take a look at each of these numbers here. We got 11, 12, 13, 14, 15, 16, and 17. We just want to know how many primes we have. And again, as I say, some of you will know these primes. Okay? Some of you might be able to pick it out right away. It's going to be 11, 13, and 17. That'll be 3 primes. Okay? But, if you have to work your way through it, ask yourself, 11, can I write 11 as some number times some other number? And, you might think for a moment and say, I can't really think of any way. If you got a calculator handy, of course, try some numbers. 2 times 5 is 10. Well, that's pretty close to 11, but it's not quite there. Okay? So you might try 2 times 6, but then that's 12, and that's too much. So you might try 3 times 4, and that's 12, and that's too much. You might go a little lower. And you can certainly experiment that way. Okay? But you'll run into this sort of a roadblock pretty quickly, and 11 doesn't really have two factors other than 1 and 11. There's no way to write it as a product of numbers that don't involve 1. Okay, so 11 is prime. So 11's prime. We'll put a little box around him. Now 12 isn't prime. I could write 12 as 2 times 6. Neither of those is 1. So that means 12 is not prime, or composite. 13, again, you can play around for a little bit, but you'll find there's no way to write 13 as anything except 13 times 1. 14, well, even numbers are actually pretty easy. 14's even. It's 2 times 7, so that's off the list. And jumping ahead, 16 is 2 times 8. Of course, it's also 4 times 4. There's lots of ways to write it, but the point is, I have written it as a product of two numbers, and neither of those numbers is 1. Now, we talked a little bit about 15. 15 is not even, but if we do a little work, 3 times 5 is 15, so that's also not prime. And 17, you experiment around a little bit, you'll find 17 is prime. So we get 3 primes, and that's all they were asking for in this question. 3 primes, that's going to be D. Okay? Now, I can tell, some of you will say, okay, that's question 3, we're done, that's good. Let's move on to question 4. And if you want to, fantastic, stop the video, I'll see you for question number 4. But some of you, some very special few of you, will not be comfortable with prime numbers, and so you won't immediately say, oh, it's 11, 13, and 17. But you're also very inquisitive, curious, and very rigorous people. Okay? And you might say, well, yeah, just because you couldn't find two numbers that multiply to 11 doesn't mean there aren't two numbers that multiply to 11 and neither of them are 1. Maybe you just didn't look hard enough. Okay? So is there a better way to test whether or not a number is prime? Absolutely. Absolutely. Okay, so here's one quick way. Well, quick depending on how big the numbers are. So I'll show you one way to ask if something's prime. So if I've got a number like 11, and I want to know, is 11 prime? Well, if 11 were not prime, if it were, 12 is 2 times 6, suppose I could write it as, one number A times another number B. Well, if that were the case, just like, 12 is 2 times 6, if I rearrange this, divide both sides by 2, I'll get 12 divided by 2 is 6. Okay. So a quick way to tell whether or not 11 is prime is ask, if I divide 11 by some other number, some number other than 11 and 1, do I get an integer back out? And this is exactly the sort of thing you can use your calculator for. So I would say, okay, 11. I'll divide it by, not by 1, because that'll just give me 1 times 11. And that one's obvious. But 11 divided by 2 is 5.5. Well, that's not a whole number. So we try again. 11 divided by 3. 3.66. Well, that's not a whole number. How about 11 divided by 4? Well, that's 2.75. Not a whole number. 11 divided by 5. 2.2, not a whole number. 11 divided by 6. 1.8, no, that's not a whole number. As soon as I see a decimal and then some other numbers, I can move on. So that was 11 divided by 6, right? How about 11 divided by 7? Well, it's going to be 1.57 something or other, but we move on. 11 divided by 8, 1.3 something. 11 divided by 9, 1.22 something. How about 11 divided by 10? That's going to be 1.1. And we run out of numbers. You can do 11 divided by 11, but that'll be 1. And then you'll just get, well, 11 is 11 times 1. But we knew that. We were looking for something else. And if you, know a bit more math, you can make that process a little faster. If you want to hit the, a lot of calculators have a little square root button. Mine has a second function square root. But if I take the second function and square root 11, I see the square root of 11 is about 3.3. That actually means I only need to do this for 2 and 3. As soon as I'm bigger than the square root, I could stop. And that makes things a little shorter. But how would this same process show me that 11 is prime, but 12 isn't prime? Well, I grab my calculator, and I try something like 12 divided by 2. I get 6. How about 15? 15 divided by 2. Well, that's 7.5. Okay, that didn't work. How about 15 divided by 3? Well, that's 5. Suddenly I've found a factor. And so this is a way that you can actually make sure that you're not just missing something, you're not just forgetting something. You actually know that 11 is prime, and that 13 is prime, and that 17 is prime. Now, it takes a little while, even if you're madly clicking buttons on your calculator, but it's a way to know for sure. And if you're someone out there who said, well, earlier when you said play around with it and you'll find 11 is prime, if that didn't convince you, you, my friend, might actually end up being a real mathematician someday. Because it's a real mathematician who will stop and say, no, how do you know? How do you know you didn't miss something? How do you know for sure that this is prime? Okay? But we don't have to worry about that. It's question 3 on the contest. There's a quick way to work with primes on your calculator. Yeah, it'll lose you a little bit of time. So maybe memorize a few prime numbers. But either way, we can move straight on to question number 4.